Hello, it's Mr. Shrum again, and I am back with a physical science mastery test walkthrough. And today we're going to look at collisions. And a collision is when two objects come into contact with one another. And we can look at how the force of the impact changes the motion of the objects. So think of, when two balls hit each other. Think on a pool table, billiards table, or two bouncing balls, and they hit each other. Well, they can speed up, slow down, change direction. And if you remember Newton's third law, they exert an equal and opposite force on each other. So if they hit each other, they're going to this ball will exert a force on that ball, and this ball will exert a force on that ball. And what happens after that is what we're going to look at today. Now, there are two types of collisions. We refer to them as elastic and inelastic, and in just means not elastic. So, what exactly does that mean? Elastic is referring to two objects with hard surfaces, and after the collision, their shape does not change. So, for example, two marbles, they're made of a hard substance, they hit each other, and then they bounce off. That is an elastic collision. Now, an inelastic collision is when two objects with surfaces that can change shape hit each other. So think of, let's say, balls of clay, right? Clay can change shape and form a new uh, object, or the object can have a different shape, right? So if two soft surfaces hit each other, they could break or change their shape in some way. And that's all that really means. And for this lesson, you do not need to know much more beyond that. Just remember that elastic objects are with hard surfaces, and most of the collisions we're going to look at today are elastic. Inelastic, you'll run into that in later sciences if you pursue physics at all. But for the sake of this lesson, we're going to look at elastic collisions. So I brought up the third law before, the equal and opposite reactions. And now we're going to talk about acceleration and Newton's second law, because that comes up again with collisions. The second law stated that force is equal to mass times acceleration. So the force an object experiences or exerts is equal to the mass times the acceleration. So after the collision, the force on each object changes the object's velocity. And a change in velocity equals acceleration. So we can look at how the change in velocity determines the acceleration, or how the collision accelerated the objects. We can look at the final speed after the collision minus the speed the objects were going before the collision and the amount of time it took, right? So that's all that really means. See, V initial is the velocity before collision. V final equals the velocity after the collision. And one last thing before we get into the actual problems is to remember the direction of acceleration. And the easiest way I can think of to describe this to you is to think of a number line. See, let's say we have 0. The number line has a center of 0. And then if you move towards the right, you're moving in the positive direction. But if you move towards the left, you're heading in the negative direction. So positive and negative are just telling you which direction the acceleration is moving, okay? If it's positive, the object is going in this direction. If it's negative, the acceleration is going the opposite direction. So let's get into the actual questions. And the first question dives right into the conceptual side of things. Oh, let me get that on camera. So what situation describes an elastic collision? And then you're given multiple choices. Well, if you remember what elastic means hard surfaces. Hard surfaces. So we have two glass marbles bouncing off each other. That's one example. And then another example would be a bowling ball knocks over 5 pins. Or any amount of pins. Okay. And this is elastic because glass marbles are hard surfaces. They don't change shape after bouncing off one another. And the bowling ball and pins do not change shape as well. So those two are elastic collisions. All right. All right. So we can move on to the next question. And we're told Erica throws a tennis ball against a wall. So she's just throwing the ball against the wall and it bounces back each time. So which force sends the ball back to Erica? Well, if you're throwing the ball, Erica's applying a force. And then it hits the wall. And if you remember Newton's third law, there is an equal and opposite reaction. So the equal and opposite force would be the normal force from the wall. See, that's the wall. She threw it this way, and it's going to bounce off the wall with the force going in the opposite direction. Okay. Did you get that one? Okay. And then the third question is asking about the unit of measurement of force, and that is Newton. Think of Newton's 3 laws of motion. They named the unit of measurement after him. So Newton, or N, is the abbreviation. Cool. Then the fourth question. Denise is conducting an experiment. She's measuring the acceleration of a falling object when it slows down and stops. So she's dropping something to the ground. And she's measuring the force when it hits the ground. So her object has a mass of 0.5 kilograms. and she measures the force when it hits the ground, and the force is 4.9 newtons. What is the acceleration of the object when it hits the floor? And we're going to use F equals ma from Newton's second law of motion. And we can just plug it in. We know the force, F, is 4.9 newtons. We know the mass is 0.5 kilograms. And all we need to do is solve for A. So 4.9 divided by 0.5 will give you 9.8 meters per second squared. Got it? Cool. And 5, a golf ball strikes the ground and exerts a force on it. Which statements are true? So like the first question we went over, you're going to be given multiple choices, and 2 of those are correct. So if a ball strikes the ground, it exerts a force on the ground, and that force has an equal and opposite force acting against it from the ground on the ball. Okay, so golf ball exerts an equal the golf ball exerts exerts a force on the ground. The ground exerts an equal force on the ball. And a golf ball hitting the ground is a collision. A ball hitting the ground is a collision. So we have ball hitting the ground, a collision. The ground exerts an equal force on the ball, and the ball exerts a force on the ground. Okay, got it? Cool. Cool. Moving on. All right, so number 6, we're dealing with a flying coconut. A flying coconut. So the coconut moves at a constant velocity of 20 meters per second in the positive direction. So we'll say to the right is a positive direction. The coconut hits an object and moves in the opposite direction. So the opposite direction would be the negative direction. And now it has a velocity of 10 meters per second. What is the change in velocity of the coconut? So the coconut was going 20 meters per second in the positive direction. And then after the collision, the velocity is going the other way. If there's a change in direction, there's a change in the sign. Okay. So positive 20 meters per second before collision, and now it's going, it has a negative velocity because it changed directions. And now you just need to find the change in velocity. And delta V equals the final V minus the initial V. And the tricky part here is to remember the negative sign for this final velocity. Because it changed direction, it is now going in the negative direction. So you have to put that into the equation. So we have a negative 10 meters per second minus the initial velocity, and that was a positive 20. So we leave that one positive. So it's negative 10 meters per second minus a positive 20 meters per second. And that will give you negative 30 meters per second. So remember that the sign tells you which direction something is moving in. So you got to pay attention. Don't let that trick you, okay? Some of these questions will test to see if you know what you're doing. So we do want to know what we're doing. But yeah, that's the change in velocity there. Got it? Cool. Yeah, so the change in velocity, we're given that. And then if we were given a time, then you could find the acceleration, but you don't need that for that problem. Seven, you're asked about car collisions. And two things to remember about cars. If one car hits another car, even if one car is moving and one car is not moving, they both exert a force on each other. Cars exert equal and opposite forces on each other. And the ends of the car, or certain parts of the car, are designed to crumple. And the crumpling lowers the force of the impact. And this is a safety feature of cars. The crumpling reduces the acceleration of the other vehicle and your vehicle too. And then that reduces the force that the passengers experience. So that will relieve some of the force from the passengers and pass it through to the car. So the car will get damaged and crumpled up, but the passengers inside will hopefully not suffer severe injuries or as severe injuries. But yeah, cars will exert forces on each other in a collision, and the cars are designed to crumple to reduce the force. Then we move on to 8. You're told about steel balls and rubber foam balls, and the main takeaway here is that these steel balls, they have a harder surface, so the force of the impact is greater, and because it's hard surfaces, it's elastic. So these three kind of go together. Hard surface, force of the impact is greater, elastic collision. The other balls are made of rubber or foam. The force is less. The force of the impact is less. And these are soft surfaces. So that is an inelastic collision. Hard surface is elastic. Softer surfaces, inelastic. Because some of that force is absorbed. So hopefully you understood that. And then if you have any questions about that, I can clear some things up for you if you message me in Canvas. And then number 9 on my teacher problem workbook, what's the force of a pitching machine? So if you've played baseball or seen some type of machine, it's like a kind of shaped like that. And then there's like this belt and it feeds the balls to the pitching, and then it'll shoot out a baseball or softball, and then someone over here with a bat will try to hit the ball. So it's a baseball training machine. And we're told that the velocity of the balls reach 30 meters per second, and their mass is 0.15 kilograms. And the machine accelerates the baseball from 0 to 30 meters per second in 0.5 seconds. So within half a second, the ball goes from stationary, 0 meters per second, to 30 meters per second. And we'll be using F equals ma because we want to find the acceleration and then use the acceleration to find the force. So first of all, we need to find acceleration. And we know acceleration is the change in velocity over time. The final velocity is 30 meters per second. That's the velocity after it releases the ball, minus the initial velocity, which is 0, because the ball starts from 0 and then it accelerates up to a velocity of 30 meters per second. So in this equation, we have 30 meters per second minus 0 meters per second all over the time it takes, and it takes 0.5 seconds. So we have 30 minus 0 all over 0.5, and that equals 60 meters per second squared. So that's our A. And then we use F equals ma to find the force. We know the m is 0.15 kilograms, excuse me, is 0.15 kilograms. And now we have the A, so it's 0.15 kilograms times 60 meters per second squared, and that will give us 9 newtons. Okay, awesome. And then the last problem deals with a free body diagram. We're drawing out when a ball bounces off the ground. And all you need to know is the ball hits the ground, it exerts a force on the ground downward, and then the ground exerts a force on the ball upward. So that's what it will look like for number 10. Not too hard. Hopefully you understand that one. And that's it for collisions. So thank you guys. I hope that helped. And I will see you all later.